Hello, I'm Eva Damon, and I go to the United States Air Force Academy. And this summer, I worked with Dr. Isaac Isukapati on forming an auction-based multi-agent UAV ISR dynamic mission planning system. This work was supported by the National Robotics Engineering Center and Robotics Institute Summer Scholars at Carnegie Mellon University. Just to give some background to this problem, it's very important that military operations be strategically sound, both for optimal efficiency and for minimizing damage and lives lost. An abundance of resources is not enough to form an ideal mission. It's much more essential to properly allocate those resources. So with that being said, some related works that I looked into was trying to determine the most efficient way to go about this problem. So I found that decentralized asset management is slightly less optimal, but much more timely and scalable than a centralized approach in which one main system determines each subsystem's routes. Using a decentralized approach in which each subsystem determines their own routes, it's slightly less optimal, but the cost-benefit analysis shows that overall the scalability and timeliness outweigh that slight disadvantage. It's also more optimal to have a real-time system rather than an offline approach where the system would not be adapting to changing constraints and parameters. I also found that in this research, auction-based systems with one swarm of drones are available, and I was able to use that to apply to a system with multiple swarms. So the objective for this problem is to develop a scheduler in order to use these swarms for ISR, intelligence, surveillance, and reconnaissance, mission planning, and execution to help ground troops. So essentially what will happen in the real world when this system is implemented is ground troops will say that they need to travel from point A to point B, and this system will efficiently put those requests into a queue, and reconnaissance drones will see those requests as shown in the figure in the method section. These reconnaissance drones will see those requests and bid on them. So as in the auction-based system name, they will see the proximity to each of these requests, and depending on the fuel that they have left and the other targets that they already have bid on and accepted as their own objective, they will determine if how much to bid on this system, or that target, So each drone is going through that, and when the adjudicator decides that this certain drone should pick up that task, the schedule of each drone is updated, and the TSP, Traveling Salesman Problem Solver, forms an efficient route between all of those targets. Now that information is then passed on to the multi-drone reconnaissance database, and essentially the same thing happens with assault drones. So that data, including the target type and the prioritization of that target, the importance relatively for determining more intelligence and maybe neutralizing that target, are entered into another queue, and essentially the same process occurs for the assault drones. So they have a bid computer, and they bid this time using priority as a main component, and the schedule updates and the TSP solver operates in the same way. Now once this system is finished, the adjudicator will see the final schedule and the problem will be fully executed. In the real world, this would be all created from ground troop requests, but in this instance we created a statistical and physics simulator in order to randomize and generate those requests. Now, as far as results, I have not finished the auction-based scheduler algorithm yet, so I'm still working on that, but there should be results coming out shortly. Now, as far as future work goes, integrating the system into the real world, as I mentioned, will be the true test to how this system works. Thank you so much.